Okay, so today we're going to look at vector operations and unit vectors, and I want to remind you to answer the discussion question that is in Schoology for your attendance today. Okay, so we looked at vectors yesterday, what component form meant, some basic stuff, so we're going to look at some operations with them. So we're first going to talk about multiplying by a scalar. Okay, so that scalar might not be a word you're familiar with. So a vector can be multiplied by a real number. Okay, so we have to have a real number. We use a lowercase k, and it's called the scalar. This will change the magnitude of the vector. Okay, so the vector will be longer or shorter, depending. If k is negative, the vector will reverse to the opposite direction. Okay, and the figure to the right shows some various ones. So if this is vector v, right, then this is 2 times v, so it's twice as long. Same direction though, so it's the same angle. Half of v means it's half as long. Negative v, same length, but it's going in the opposite direction. Okay, so when we add them, so a geometric representation of the addition of 2 vectors is shown to the right. The vectors are positioned so the tip of v coincides with the tail of w. So we have v plus w. So here's v, and then when v ends, w begins. So you draw them next to each other. That's how you would attach them. And then this right here, this part, that is v plus w, and that is called the resultant. So it is the resultant vector. When you subtract them, that's the difference of the 2 vectors. So if we have v minus w, we really want to think of it more as addition, v plus negative w, because that negative is going to flip it around. So here's the difference, and it's the tip to tail method. So here's v. Notice it's the same v as this was right here. This w, that's negative w, so it was this one, but instead of going in this direction, it's going in the opposite direction. So it's here. So that's what makes this v minus w. It's really v plus, and then we have negated w. This right here is then your resultant vector. Okay, so that's how it happens geometrically or visually. So let's look at it algebraically, what our rules are. If we have vector v, it's a1, b1, w is a2, b2, and k is a real number. So scalar multiplication, k times v, that would be equal to, and then this is v, a1, b1, so it's going to be k times a1, comma, k times b1. It's that easy. You just multiply whatever the scalar is by both of the numbers. If we're going to add the 2, then you literally just add them like you would ordered pairs. So this would be a1 plus a2, and then b1 plus b2. If I'm going to subtract them, then it would be a1 minus a2, and then b1 minus b2. So it's as it would seem, what you would think would be actually happening there. So let's look at number 1. I've got 2 times c. All right, so here's c. It's negative 4, 5. So that means that 2 times vector c would be equal to 2 times negative 4, and then 2 times 5. So that means that 2 times vector c would be equal to negative 8, 10. There's my answer there. Number 2, I have vector c minus vector b. So vector c minus vector b equals, so this would be negative 4 minus b, which would be 1, and then 5 minus 7. So vector c minus vector b equals negative 5, negative 2. Okay. So why don't you pause, do number 4. Oh, the first number 4, because my numbering's wrong. Yeah, welcome to my world. So pause, do this one, and then unpause, and we'll see if we agree. But I'm going to keep going since this is just a video. You have control over pausing, rewinding, so forth and so on. All right, so A minus 3C, it's going to be, oh, I can't see him now. A would be negative 6 minus 3 times negative 4. And then the next value would be 2 minus 3 times 5. So A minus 3C would be equal to, so this is going to be positive 12, so that would be a positive 6, 15, negative 13. There you go. All right, so number 4, another one of my fraction bars disappeared to Neverland. If you haven't already done the second number 4, then pause, do that one, and then unpause, and let's see if we agree. So 1/2 times vector A minus vector B equal to, well, I keep scrolling and I can't see. So this would be 1/2 times negative 6 minus 1, and then 1/2 times 2 minus 7. So 1/2 of vector A minus vector B equals, so that'd be a negative 3 minus 1, so that's negative 4. It'd be 1 minus 7, so that'd be negative 6. So that's what I got. Before we move on to the next part, I want to show you a couple of things in Delta Math. So we're going to start with this one. So it says, given these vectors, we want to find the sum and write the resultant in component form. So let me see if I can make this a little smaller. All right, so I have U, which is 8, negative 4, so this is that vector. And then V, which is negative 2, negative 5. That's this vector. They're both drawn. They're both in standard form. I want the sum of U plus V. So this is U. I'm going to grab V. I'm going to drag it here. Got that tip to tail going on there. So there's U plus V. So I can see graphically, I mean, I can also add. So I know this would be a 6 and negative 9. But then this right here, which I can't draw in, but this is my resultant vector. And to get to that, I would have to go to the right 6 and down 9. So my answer there would be 6, negative 9. So then here, I just type in my 6 and negative 9. Submit my answer. Yes, and I'm right. Yay. Okay, so let's look at another one. Different kind. So we are going to do negative 2V graphically by stretching the vector. So this is a negative, which means I have to reflect it. It's going to go in the opposite direction. So if this is negative 3, negative 4, that's this vector right here. I want it to be twice as long, but going in the opposite direction. So I'm going to grab it, and I'm going to stretch it this way. So now it's positive 3, positive 4, but I want it twice as long. So I go there to where it would be positive 6, positive 8. That's what it looks like. And then I have to write it in component form. So that's going to be 6, 8. Oops. All right, let's look at a different one. So here we're going to subtract them graphically. It's going to guide us through doing it a couple of different ways. So if I'm going to subtract these, this is going to be, it's going to be U minus V. It's going to be 4 minus a negative 2, so that gives me 6 right there. And then 3 minus 6 gives me negative 3 right there. So I'm supposed to try it, can't move on unless I'm right. So it says, okay, I'm right. So now it's telling me what to do. You got to follow these directions. So it says find U minus V by adding U plus a negative V. So here's U, here's V. See this whole thing here? This is going to negate V for me. So if this is V, that's my negative V. So since I'm subtracting, I'm really adding U plus a negative V. So I take U, here's my negative V, I'm going to drag it tip to tail right there. So it says great, because it's telling me I'm right. that it says, now draw the resultant vector from the origin. So I'm going to draw that right there. That's my resultant vector, and that shows me that that is 6, -3. Okay? And which is what I had. Then it's going to tell me to do it a different way. So another way that you can do these subtractions is instead of, if I want to do u minus v, I have, instead of negating v and then, moving it, I can leave them here, and if they're both attached at the tip right there, then I just draw it like this, and that's the same one, shows that I'm correct, and I submit my answer. So 2 different ways to do it. I think negating it and moving it being consistent like the first way, that's the way I prefer. All right, one more before we look at the second part. So it says, we've got these vectors. We are going to determine the value of 4v minus 3u, and we're going to click and drag the dotted vectors as many times as needed. All right, so I have 4v minus 3u. So u needs to be negative. Here's v, here's u. I'm going to negate u, so there we go. I want 4 of the v's. So here's v, and I need, oops, grab the wrong one. I know I grabbed the wrong one. You grab this, and I want, how many do I want? I want 4 v's. So 1, 2, 3. So that gives me a total of 1, 2, 3. I have 4 v's. I have a negative u there, so I need 3 of those. So add the 1, 2, 3 negative u's. All right, so I have 4 v's, 3 negative u's. That means when I connect these to get my resultant, which on this one it's not going to let me click and drag anything, that's going to be 3, 8. Three, 8. Submit my answer. Yay, I'm correct. Okay, so I have one more to show you, but that's after we do the second part of this lesson. So now we're going to look at standard unit vectors. Okay, so standard unit vectors, I and j, they are always I and j. You can name the other vectors anything you want, but these are always I and j. They are positioned along the x and y axis. So unit meaning that this is 1. So this is I because it's 1, 0. This point is at 1, 0. J is at 0, 1. So the vector for I is 1, 0. The vector for j is 0, 1. So notice I wrote a vector here. These are ordered pairs because those are actually points, but I can move those vectors anywhere I want. Okay, so any vector v that is in the form of AB, which is really any vector that we know right now, can be written in the form v equals a times I plus b times j. So we're taking the a and the b and multiplying them by these vectors. This is called a linear combination of vectors, I and j. So it looks like this, and we're going to prove this here. So we're going to rewrite this as the sum of 2 vectors. So another way to write this, so I could say vector v is a comma 0 plus 0 comma b. Those are the same thing, because if I add them together, then I get AB. So now I'm going to factor out a and b. So if I factor a out of this, this is going to give me a times 1, 0 plus b times 0, 1. And then I substitute a and b, or I'm sorry, I and j. So instead of 1, 0, that's going to be I. Instead of 0, 1, that's going to be j. So I get vector v is equal to a times I plus b times j. And it's really vector I and j. Sometimes they're hats, like you can have, but they're bold up here, and we can't really write them bold, so we'll do them that way. So it says rewrite each vector as a linear combination of I and j. It is this easy. It is just a different way to write it, a different way to notate it. So v is also equal to 2 times I plus 5 times j. And these are either bolded or actual vectors, but I'll make those bold and I'll make these vectors. So you try this on this one, vector n. Rewrite it as a linear combination. Be negative 7 times I, oh, that's a j, goodness gracious. I comes first. I plus 3j. In order for me to do that on number 3, I have to get this into component form first. So vector rs in component form, remember it's rs, so I have to do s first when I subtract. Negative 5 minus a negative 9 is going to be a positive 4. And then negative 6 minus 8 is going to be negative 14. So that means that vector rs is 4i minus 14j. You do number 4. Okay, there you go. Now let's look at one thing on delta math with I and j. So we have these standard unit vectors, I and j. We're going to click and drag copies of these in order to create the resultant vector. So they've given me the resultant vector. I'm going to show how the i's and the j's work. The i's and the j's, so I is attached to the x-axis. So if I was to get this vector, this would be a positive 4i. So here's 1, and then 2, 3. See, it takes 4 of those unit vectors. That's why it's 4 times I. But then I'm going to have a negative j, so I'm going to need to negate that j. And then it's going to have 1, 2 of those. So it took 4 i's and negative 2 j's to get that. That's where that 4 negative 2 comes from, and that is why we're writing this as 4i, that's not 45, 4i and negative 2j. And I'm going to try it. And then it says show numerically why this is true. So when I show numerically why this works, if I distribute this back out, this gives me 4, 0. This gives me 0, negative 2. I can try that. I am correct. And then I submit. Okay, so I wanted to make sure that you knew what was happening in Delta Math and on your notes there. So make sure that you get your discussion question done and work on the Delta Math from yesterday if you haven't already finished that, and then your Delta Math assignment for today, and I will see all of y'all tomorrow.